Welcome to lecture 16 of Basic Electrical System course. In today's lecture, we will see the different examples of a parallel circuits, how we can determine the unknown quantities in a parallel circuit. So let's start the lecture. Now, in case of parallel circuit, the following things need to be calculated. The first important thing is the total resistance of a parallel circuit. Second important parameter is the current flow through each branch as well as the total current flow in parallel circuit. And third important parameter is voltage drop across each resistance. Coming on this first problem, in the diagram, you can see two individual resistors R1 and R2 are connected parallelly to the voltage source. The current of 2 amperes is provided through voltage source. We have to determine the supply voltage. So we can determine first of all what is the equivalent or total resistance of this parallel combination. So that is given by multiplication of individual resistances or the product of individual resistance divided by the sum of individual resistance. That comes around to 6 ohms. Using this value of equivalent resistance, we can determine the supply voltage. As we already know, 2 amperes is coming from the battery. If we multiply with the equivalent resistance, it will give us the value of around 12 volts, which is the supply voltage. Now coming on the next problem, here we know what is the supply voltage. We know the current flowing from the positive terminal of the battery. In this case, 3 individual resistors are connected parallelly. The values of 2 resistors is known, whereas the value of third resistance is unknown. We have to find out this. So let's proceed. First of all, we will find out what is the value of the equivalent resistance. Simply we have to put 12 volts divided by 12 amperes will give us the value of equivalent resistance that comes around to be 1 ohm. Okay, so by using the formula of 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So if you use this formula, here there is only one unknown value. From this we can determine what is the current flow, what is the third resistance in this system. Now coming on to the next problem, here the individual resistances are provided. 4 ampere current is flowing, so we can determine the equivalent resistance. That comes around to be 3 ohm. 3 ohm multiplied by 4 ampere will give us the total supply voltage of 12 volts. Now in this case, 3 individual resistors are provided, R1 plus R2 and R3. So we can determine the what is the equivalent resistance. That comes around to be 1 upon 8 plus 1 upon 8 plus 1 upon 1 divided by 4. So it is around 4 ohms. It is around 2 ohms. Okay, so this 2 ohm resistance we know, that is equivalent resistance, divided by the supply voltage will give us the 6 amperes of current which is flowing through the positive terminal of battery. Now there are certain problems in which the loads are connected in a series parallel combination. This series parallel combination is called a combined or a combination circuit. Many automotive circuits include sections that are parallel and in series. A series parallel circuit includes both parallel loads or resistances, plus additional load or resistances that are electrically connected in the series. There are two basic types of series parallel circuits that we are going to see. So see here, in this case, a circuit where the load is in series with other loads are in parallel. An example of this type of circuit is a dash light dimming circuit. The variable resistor is used to limit current flow to the dash light bulbs which are wired in parallel. Now, a circuit where parallel circuit contains resistor or loads is in series in one or more branches. A headlight and a starter circuit is an example of this type. A headlight switch is usually connected in series with the dimmer switch and in parallel with the dash light dimmer resistor. The headlights are also connected in parallel along with the tail lights and the side marker lights. Now to determine the series parallel circuit faults. If a conventional parallel circuit such as a tail light circuit has a fault that increases the resistance in one branch of the circuit, the current flow through that one branch will be reduced. Added resistance due to corrosions or similar cause would create a voltage drop. As a result of this drop, a low voltage would be applied and the bulb in the tail light would be dimmer than normal. Because the brightness of the bulb depends on the supply voltage and the current applied, the low voltage and the current would cause the bulb to be dimmer and dimmer. If added resistance occurred in one part of the circuit that fed both tail lights, then both tail lights will be dimmer than the normal. So in this case, the added resistance created a series parallel circuit that was originally just a simple parallel circuit. I hope you understood this lecture. If any students having these doubts regarding the series parallel combination, please feel free to drop a mail regarding your doubts. Thank you for today.